Life is meaningful. You are real. This is quantum consciousness. Please like the video, subscribe to the channel, leave a comment below, and write a review.
Join me deep inside the mystery of numbers. Come and huff a metaphysical new. See how concepts become objects and then become qualia. Join us for an episode of Quantum Consciousness.
Hello, my name is Justin Riddle, and I'll be talking to you about quantum consciousness. This is the first video of my series, and the plan is to give you some very basic introductory arguments for why quantum consciousness is worth your attention and worth considering. All of my thoughts about quantum consciousness were developed over the last decade or so, essentially culminating in me teaching a class at UC Berkeley entitled Quantum Consciousness for 7 years, and it was my pride and joy. And this is really sort of a translation of that course into a series of videos for you out there. All right, so I'm going to start off with the first reason for why quantum consciousness is probably worth thinking about more critically. And so the first argument is people have always identified as their latest technology. The first example that I have heard, I don't quite remember where I heard this, is that the idea that people, believe it or not, identified as irrigation systems. So when they invented agriculture, there was this breakthrough technology that you could move water around a field in sort of a systematic manner. And people thought, oh, this is maybe how the brain works. There's thoughts, they move around systematically. It sounds kind of quaint and trivial in this modern era, but I question you to think about to what degree this sort of simple line of thinking is still happening now. Since then, there's been this notion of writing with the advent of books and scripts, this notion that perhaps the mind is like written word or written language. And so the basic idea there is that, your thoughts are written down in your brain somehow, and the advent of writing is somehow related to our cognition directly. Since then, some of the more lasting modern day theories on consciousness come about from the industrial era, this notion that your brain is like a machine and that there's all these cogs and wheels going on, and somehow consciousness is occurring, and it's maybe a mechanical system of levies and pulleys. And now we live in the digital era, right? So we've moved beyond industry, and sort of the next stage in human technology was digital computation, digital information, and now we have digital computers. And I would argue that it is very commonplace nowadays to have the theory that your brain and your mind is a digital computer. We hear this all the time. People refer to thinking as somehow computing. Memory is sort of given this storage capacity limitation, similar to how we think about a digital computer. And a lot of people in academia, in the world, intellectuals broadly, think about the brain as a digital computer. All right, what's the problem with that? Well, I don't think there's anything necessarily wrong thinking about the brain digitally, but I think there are a few limitations. The biggest one is that quantum computers are here. There are now quantum computers being developed primarily at Google, but also by other companies. And essentially, digital computation is in fact a special limited form of quantum computation. And there is a simple way to derive digital computation from a quantum computer. But more importantly, this should really shake up the way that we think about ourselves. Imagine a future not too far from now when we have quantum computers in our homes, on our, in our phones and on our desktops. And we wouldn't want our computers to be more intelligent or more powerful than our own brains. So I think once we reach a point where we all possess quantum computers, they're among us, I think we'd be hard pressed to really say that this computer that you've purchased is more powerful than your brain and more powerful computationally than you. So I think that is sort of a simple argument for maybe keeping up with the times, right? So now we all identify as digital computers, mainstream opinion, but very nearly in the future, why not start identifying as a quantum computer? All right, so that's sort of a simple argument for that. What makes quantum computers so special? Well, there's plenty of reasons, and part of this channel is to go through these different reasons. But broadly speaking, they have a much higher computational capacity than digital computers. And a fun fact is that in 2019, this was the year, 2019, that we achieved quantum supremacy. And quantum supremacy is essentially when a quantum computer runs an algorithm and computes the solution to a problem that could never have been computed on a digital computer before the death of the universe, right? So it's a computation that would take so long to run on a digital computer that literally the universe would be destroyed before the computation finishes running. However, the quantum computer computes it in fractions of a second and gives you a solution. So this is really important because it's kind of a landmark, groundbreaking moment in our history, and it should really shake up the way that we think about consciousness, right? So if you have a metaphysics or a theory of mind, and in that theory of mind, there is no quantum computer, well, then you're kind of missing a huge aspect of reality, essentially. So I think that it is only a matter of time before this becomes more and more commonplace. And while quantum consciousness seems like a controversial novel hypothesis or theory at this stage, I really think it's just a matter of time before it becomes more or less commonplace. All right, the next point. So while quantum computers are here on the technology side, on the scientific side of investigational science, I guess, quantum biology is here. And what evidence do we have of quantum biology? Well, at the chemical level, it's very obvious that quantum mechanics is involved. There's no question there. Chemistry is often cross-listed with quantum mechanics. People who study chemistry need to learn quantum mechanics in order to become literate or to understand the field of chemistry better. And it's gotten to the point where proteins are now understood to have quantum principles at play. All right, so we have proteins, chemicals, obviously smaller molecules are quantum mechanical. So where do we draw the line, right? Proteins are quantum mechanical. What about, systems of multiple proteins? Is that quantum mechanical? What about a cell? Is that suddenly not quantum mechanical? And so we have to draw a line at proteins. And you can see that this is actually a much more sticky situation than you might want to believe, where you have to draw a line somewhere if you don't believe that quantum mechanics matters at the cellular or brain level, right? So you have to start drawing a line in the sand and saying it happens here, but not there. So I would argue that it's only a matter of time before we start moving this line higher and higher and higher until the point where essentially quantum mechanical principles are at play in neural activity. And then at that point, a lot of theories of consciousness are grounded in the brain. At what point is quantum mechanics now playing a role in consciousness? All right, so what are some good examples of quantum mechanics sort of breaching into higher and higher levels of biology? Well, a really good example was the discovery in 2007 that quantum mechanics is playing a role in photosynthesis. And there's been plenty of follow-up studies to this original presentation in 2007. But the idea is that in order for light to get harvested into usable energy in a chlorophyll cell, the light needs to be transferred into reaction centers in the cell. And what was discovered is that in these chlorophyll cells, the transfer of light is at near 100% efficiency. And this vastly kind of outperforms at least modern human technology, but also suggests that there needs to be some sort of quantum mechanical safe space to maintain the coherence of the system such that you can achieve these near 100% yields. And so I think this is like a very subtle but powerful point, is that while humans are inventing solar panels and solar technology, we still are not at the level of a blade of grass, right? There's these big multi-million-dollar corporations building solar panels, and yet we're still trying to figure out how an individual cell in a blade of grass is able to process light to the efficiency that it does. And we still have not yet reverse engineered photosynthesis. All right, so just to like put biology in perspective, biology is pulling off technological feats that we are not able to do yet. So I think this is a critical thing to understand. And one of the reasons why we might not have been able to do this yet is quantum mechanics. We haven't fully understood quantum mechanics, and we haven't fully realized it in an artificial setting. And so it's no wonder that we haven't, outperformed grass with our technology yet. All right, so an argument against quantum mechanics in biology or in consciousness or in the brain is that it's just too warm, wet, and noisy in the brain in order to sustain these subtle, fragile quantum mechanical effects. And so the answer for that is essentially that, yeah, it is warm, wet, and noisy in the brain. And it's not just, going to naturally, chaotically come about that quantum mechanics is able to do its thing in biology, but we've had 4.5 billion years of evolution working towards overcoming this problem. And so it might be that one of the fundamental things that biology is pulling off is essentially fighting off entropy and chaos and trying to form ways of generating sustainable quantum mechanical states. And this might be really key to what biology is doing. And so, yeah, it doesn't come for free. It takes a lot of dedicated infrastructure. But perhaps our bodies have been working long and hard to be able to sustain quantum mechanical effects at larger time scales, larger spatial scales. And this might be part of the reason why humans and animals have evolved and have such impressive computational processing abilities. So it's a bit theoretical, but just because it is a difficult problem, this is really just an engineering problem of it being warm, wet, and noisy. And we need to essentially learn from biology, because like in the photosynthesis example, there's ways of carefully constructing spaces that, and systems that are able to sustain quantum mechanical states. And so we should look into those and figure out how biology is pulling this off. And we'll discuss some of the theories on how that's happening. All right, so another argument against quantum mechanics is really the argument that, well, if quantum consciousness isn't a thing out there, then why should I believe you if it's not like a mainstream thing? It seems to be controversial or one of these like debunked fringe theories. Why should I pay any attention to this? And I would argue to you that there is a long list of meaningful and important discussion around quantum consciousness, and I'm not actually sure why it hasn't, been more mainstream. But I guarantee you that you have heard of people that were proponents of the quantum consciousness theory. So since the 1920s, we had Niels Bohr, who was a contemporary of Einstein, and they would have these long conversations debating the nature of life and reality and consciousness. And Niels Bohr was really pushing for sort of a quantum mechanical description of consciousness. Others, Erwin Schrodinger, Heisenberg, more modern times, John von Neumann, Henry Stapp, David Bohm, Roger Penrose. I'll put links to all these individuals. But there's a lot of people that have been questioning and thinking about a quantum mechanical description of consciousness. And this really isn't sort of a recent advent. It's been around for now about 100 years, and there's been plenty of people discussing and thinking about this. One reason, this is somewhat speculative, one reason it might not have gained as much traction as sort of the simple physicalist relativistic theory that Einstein was pushing in particular, is that it is more complex, it is more nuanced, it invokes a lot more mystery, and I think there is a appeal that the more physicalist, reductive theories of consciousness have, in that they seem to be more grounded and they seem to be more tractable. So it's a little speculative, but that's kind of my thinking on why this isn't more mainstream. All right, my final point for why quantum consciousness is worth considering is the massive failure of physicalist theories to explain a lot of phenomena of consciousness. So there's a lot of aspects of consciousness which have really unfulfilling explanations in physical theories. And I think quantum consciousness has a lot of potential to address some of these fundamental mysteries about the human mind. And a couple of them that I'll list for you here. The notion of a sense of self. In digital computers, in a physicalist framing, there's nothing inherently that would push you to think there is a single mind or a single self in my biology. There's really nothing that would suggest that or favor that. However, in quantum mechanics, there is this notion of a wave function. And in order to make the ultimate quantum computer, you want to have one giant wave function with as much information pumped into it as possible. And so quantum mechanics much more naturally favors the emergence of a single mind or a single entity. And I'll go into this in more detail in the future. Another notion is this notion of free will, this sense that we have agency, that we make decisions, and there doesn't seem to be any reason in determinism or in the determinism that falls out of physical theories for making choices or having free will. If everything is physical, then we would assume that there are sort of these, determinants of everything. It's just this complex causal chain pushing us forward. Some chemicals, some neurons, they're all firing and activating. And this is really driving our actions. But in quantum mechanics, there is a notion of non-determinism. And I'll talk about this more in the future once again. But the idea is that there is sort of a skip in the deterministic unfolding, and there's room in quantum mechanics to have something maybe resembling free will, or at the very least, pure determinism is not the name of the game. There's more to it going on. So I think that's really an interesting way that maybe in quantum mechanics, we can, in a scientific way, salvage free will, which is obviously of utmost interest to the human experience. One final notion, which quantum mechanics might lend some light into, is this notion of relativism or self-constructed meaning. And there's this notion that comes out of a purely physical deterministic system that you have to create your own meaning. Everything is relative and everything is sort of created from the ground up in this ultimately unique and local reality. But there's this really amazing phenomena in quantum mechanics called quantum entanglement. And quantum entanglement is a way of basically violating the basic laws of time and space. So quantum entanglement allows spacelessness and timelessness, and essentially it allows for systems to be interconnected with each other despite space and despite time. And I think this is really profound because, it's a bit of a leap of faith or a jump here, but it allows for something bigger than yourself. It allows for a connection to others, a connection to some sort of universality, some spaceless, timeless qualities. And it's not, known at this point, but there is room for sort of an expanded view of the universe as being interconnected, being meaningfully related in ways that aren't just reduced to local, physical, deterministic causal chains. There's sort of a non-causality element in quantum mechanics that might be possible. So these are things that get me really jazzed up about quantum consciousness, and hopefully this served as a primer for you out there. But the point of this series is to dive into these topics much more closely. So just view this as a quick primer, and I look forward to talking to you more about this.